Starting on the Rob Roy style regulator in earnest. First thing I did was to assemble the different parts I would need, and this is a beautiful bronze tube that Fred gave me, which it was a little coated in dirt and stuff, so I cleaned it off, scrubbed it out really good, and the only thing I need to do to prepare it, I'll need to clean up that end and make it true. Obviously I'll need to cut this thing shorter at some point, but I don't know how long this assembly is going to be yet, so I'm going to just true up the end for now. The other things I've got some chunks of bronze left over here that will be the perfect size to make the flange. That would be on the back side, and then a piece of brass. It doesn't need to be bronze, but a piece of brass that I can use for the packing gland nut. Let me show you. So like I always do, I start out with making detailed drawings and step-by-step procedures for the different pieces. So here's my drawing for the rear bushing and for the packing nut, and as you can see, I've gone step by step. I've done layout and thought about, I'm going to use 6 holes instead of 8. The Rob Roy calls for 8. There's just not that much room, and I think I'm going to put them on an 800 thou pitch circle diameter. So more on that later. I'm going to start with I'll start by clearing up this tube, then I'll make the packing gland nut, and then I'll work on the rear flange. Hey, little progress update on the pieces for the regulator slash throttle. Cleaned up the bronze tube here that Fred gave me. I've already made the packing nut, I'll show you that separately, and then I'm turning this chunk of bronze down to this is 900 thousandths, that's the outer diameter of the bushing on the Tich boiler that I got, and then this diameter is just a shade over a half inch. It's like a 515 thou, which is the inside diameter of the tube here, and it's just a very nice fit, just slight push fit on here, which I think will be perfect for the regulator itself. See, it's had it on there a second ago. Let me get it on with, there we go. So nice little fit, snug enough fit on the end there. Of course it'll be screwed down, but I wanted to have that be a pretty good fit. Now I've got just drill a hole through, drill and ream a 3/16 inch hole for the rod, and then reverse everything so that I can do the machining for the packing nut. I reamed out the hole, the 3/16 inch hole for the drive rod or the throttle rod, and just wanted to show that. I've got a set of reamers that are slightly oversized, so this one is a half thou over for the 3/16. There's a flat bottom 9/32 inch drill bit that I use to make the hole. This for the tapping size hole inside the gland for the rear fitting. I get ready to tap that thing now, 5/16 32. Well, finally this looks like something worth showing, but here's the little brass hex nut that I made, and there's the bronze rear fitting. So it's threaded. I used the my tap holder, and got a nice fit there, so that'll be a good thing for the packing gland. Right now the last thing I'll do, I'll run the 3/16 inch reamer through. I misstated before, it's a 1 thou over 3/16 inch reamer, so I'll run that through here before, and then I'll take this out, and then one more thing we have to do, well, 2 more things. We need to drill the 6 holes for the 256 screws that will hold this to the back of the boiler, and eventually when we get ready to mate this to the housing, I'll put some screws in laterally, but that'll be further down the road. Here I've got the rear bushing held in a 5C collet chuck, and what I've just done is gone around and measured and marked off where the holes will be, the 6 holes for the 256 screws. 2 things, I went through this twice. I ended up using a 3/4 of an inch, 0.75 inch pitch circle diameter. First I was going to go for 800 thou, and actually that was too close to the edge, so I'm really glad I test this first. I marked it with a blue marker, and I've got the little center drill in there, and you can see it. I just did that by hand, just spinning this and giving myself a nice, the transmission's in neutral, So give myself a nice little view of where the holes are going to be and a feel for how far from the edge. So I'm going to go with this. I'm going to be drilling some number 50 holes here for that's tapping size for 256, and then I'll be able to use this as my drilling guide for the back of the boiler, and then I can enlarge these holes later. Yay! Okay, there's my 6 beautiful perfect holes. Very pleased with how they came out. So we're on to the next thing. Working on the body of the valve, the regulator valve right now. So I took a piece of the cast bronze, which is oversized, so I'm having to use my 3-jaw chuck. I turned the outside diameter to exactly 5/8 of an inch. I turned this small 1/4 inch long section to fit just inside the bronze tube that'll be the body, and I've drilled successively larger and just used this flat bottom drill to down to 1 3/4 inches, and to make the surface for where the valve will actually contact. So now I can start enlarging the back pieces, make the threaded section, and make the 3/8 inch section for the carrier bearing. Just a little recap of the making of the valve body. I've used progressively larger drill bits to open up this space. Ended up with a 15/64 inch to the required depth, but I didn't go all the way. I finished it with a flat bottom drill that I use for valves. I know I've showed this before. I have a drill index here. Whenever I need a specific size, I go ahead and make a flat bottom drill for it. So here's the 15/64. I just ground this one up fresh this afternoon. I'll show you there. So flat, and that'll leave a nice surface. It should leave a good flat finish for when I drill through here, when the pointy end of the valve goes and connects there. So that's one thing. Also, let me just pan over here and show you the valve. So there's the valve body. I drilled it out. Then I drilled it 5/16, which is tapping size, for 3/8/16. You can see how coarse that thread is. I mean, that's like an automotive size. So I went down to the required depth. I think it was 1 1/4 inches. And after that, then I went 3/8 of an inch, drilled out 3/8 of an inch by 5/8, 3/8 inch diameter by 5/8, and then I reamed it with, you can see the reamer there. And the reason I drilled and reamed was there's a little carrier bearing here that I'll need to cut this off to the required depth and then drill and ream it out 3/16, so it makes a nice carrier for the throttle rod. So there we go, that's just a nice fit in there, and this will be screwed in as well once it's cut off. There, I've made the point for the throttle regulator, and the next step's pretty simple really. I just need to thread this 3/8/16, which I'm going to have to do basically manually, I think, and then make a little back piece for it. And then cut it off and make a hole in the back. So we'll get to that in a minute, but I wanted to show the setup. It's an oddball angle, and what I ended up using to make sure I got my 60 degrees was a 1-2-3 block and a 60-degree angle plate. And here's the throttle pin, if you will, so, or screw. It's the 3/8/16, which is equivalent to a British Standard Whitworth, at a 1/2 inch and a little point at a 60-degree angle. And as you can see, I wanted to show, I left this long. I got like 1 inch of material back here because I'm about ready to put it in the lathe, and I'll leave this all together, or I'll clean up the end and then center drill and drill the depth for the 3/16 inch drive rod. But this way I can put it in the 5C collet chuck and have this part support it. I'll put it in this way. Here's the back end of the screw, the regulator screw. I've drilled and reamed a 3/16 inch hole in it, and here's this is a beautiful piece of 3/16 inch stainless that my friend Russ gave me. He ordered some extra from McMaster Carr, so it was perfect for this project. So I'll be using that, and like I said, I drilled and reamed 1 inch deep, so I can take this out. And what my plan is to leave this thing long, and you probably use the 5C chuck to hold the piece while I drill the through drill in the rod, in this end, and then I can cut it off, cut the excess off. After a productive weekend of machining most of the major parts for the regulator assembly, next thing I wanted to do is take a moment, look at the layout and think about exactly where the next things I have to do, the small details, make sure everything comes together satisfactorily. So I measured the depth inside from the rear to the wall, and it came out perfectly. It's right at 3/4 of an inch from the front there. So I'm just laying the pin out here, the regulator pin, for orientation, and I put a mark here. This one represents about where the screw will go through to hold the throttle rod into the throttle pin, and I think I'm going to use a 256. The book calls for a size that's .092. This is a little bit smaller, but I think that'll be just right for our application. I know there'd be plenty strong. So I may drill and tap that tonight with a 256. The other line I put here is basically where the gas space is, if you will, because the book calls for putting the pipe, the inlet pipe, the 1/4 inch inlet pipe, the center of it 3/4 of an inch back from the front, and if I did that it would be a little far. So what I've just been playing around with was, if you can see it, a real faint mark. Using it at 5/8 gives it a little bit more room, so I think that's what I'll do. I'll get more into that later when we make that hole, but just kind of wanted to talk about the overall layout and the fit of everything together, and just one step at a time now. Probably tonight we'll just drill and tap that hole, the 256 hole. We'll go through and hold the rod in. Then once that's done, then I can cut off the excess material here. I still want to keep this on long enough to be able to hold it in the 5C collet chuck in the mill. Here we have the pin and the rod. The rod is super glued into the pin for the throttle, and you always use I'll either file a flat or I use an end mill just to touch a flat spot. Then I use a good center drill, of course, and then what I'm using here is a number 50 drill, and I'm going all the way through, and now I'll tap it 256 for the screw. As you can see, I've got it well supported by packing underneath the pin. Well, just to dispel any rumors that everything I do works out properly, I just broke off the dang tap. I'm so frustrated. The only good thing is it was almost all the way through. I don't know if you can see the bottom of it there, and I was going to put a screw in there, but you know what? And it will be disassemblable. I'll need to cut off the end of the shaft and, machine it a little bit for the little lock nut and the little square for the throttle, but there's no way that's coming out without drilling the whole thing out, and I'm not about to do that right now. So I'm just going to grind that smooth, grind it flat and deal with it. And luckily there was enough of the tap left. I can grind this and make a bottoming tap, so all is not lost, but it is frustrating to break a tap. Well, one little complication of the breaking the tap off is that I did have to put this back in the lathe and use the cutoff tool to remove the little stub that I was using to hold on to it. I did it pretty carefully. I had to put one little groove in there in the shaft, but that's not going to hurt anything. So anyway, we live and learn. Glad I was able to share my mistake with everybody. Overall, though, I'm pleased with how this came out, and I'll have a little fixture that I can use when I machine the end of the shaft. So all is not lost. We adjust. Next thing for the regulator is the steam inlet tube, and for this one I'm going to go ahead and use a 1/4 inch copper tube, just like the plans for the Rob Roy call for. And what I did was I crazy glued a drill, I think it was a number 17 drill, inside there to give the copper tube some stiffness. And then I've just put it in the lathe in a 5C collet and filed it down a little bit and just mic'd it. And it's funny because it was oversized, but it mic'd it down so it's just a shade under 250 thou. So now I'll be able to use that with the drill in there. I'll be able to use the tailstock threading device and put a little thread on there, the 1/4 x 40. Okay, I just finished drilling and tapping the head of the throttle regulator tube, for 1/4x40 threads for the steam inlet pipe, that will, I guess the dry pipe, what you'd call it. As you can see, I kind of got an unusual setup here. I used my little Shoreline vise to hold the tube because it has a nice little notch in it there, handy for holding round things plus smaller things, and just use a succession of drills to get up to the number 5, which is tapping size for the 1/4x40. And the nice thing about having the Shoreline vise in the big vise is that once I tapped the hole for the steam tube, I made a little one so I could eyeball that thing being straight up and down. I put the little brass or bronze bushing inside there, and with a little drop of crazy glue to hold it in place and get the right depth. Then I was able to drill, center drill, and tap I'm using an 080, this tiny little brass screw, to hold the bushing in place. Okay, a pretty good stopping point for tonight, but I'm pretty pleased with, I don't know if you can see that very well, but I countersunk that pretty deeply so the head of the 080 screw is below the surface, just to make it easier to get in and out, because this thing's going to have to go through the rear tube or the rear bushing. I do need to clean out the parts inside there, and I did measure and cut this little stem. Took Julia's advice and put a little copper washer around there so I can see. I have a little air space up above where the safety is, and that's how I measured I eyeballed the dry tube, steam inlet tube. So, looking good so far. Now, the next step was cutting the bronze tube to size, and it worked out to right about 3.2 inches in length with the equipment, the Rob Roy style equipment on there. I'll show you what it looks like together in a minute. Took a deep breath. I kind of hated to do it, but I needed to, obviously, at some point. And the good news is I still have more than that left over from the tube that Fred gave me, so I'm pretty excited about that. So next step is to, I think I'm going to crazy glue these pieces inside, just dab of it to hold it all together, and then I'll drill and tap for the 080 screws this size, tiny little things, just like I did to hold the bearing in. Here's a little regulator assembly crazy glued together. I haven't drilled and tapped for the screw holes yet, but I wanted to show the relationship. See, we're right over the rear flange. It's funny with the angles, it looks like it's a lot more, but right over the rear flange and centered on the front hole. Alright, here's the assembly crazy glued together. I did take care to align the flanges in the bolt holes there in a certain direction, but I'll definitely, when I go to mount this thing, I'll drill that center 5/8 inch hole and then use the flange itself as a drilling and tapping guide for the screw holes that go around the edge. But there's the general mock-up right there. And I'm reassembling the regulator now. Just put in the screw that holds that little bearing in there. I wanted to point something out, that aligning the bearing to the hole is critical, and getting it pushed in the right length is also critical. You can see I cut a little slot and filed a little slot in the back of the bearing to make it much easier, and it was a godsend really for twisting the bearing around to align the hole. Alright, finishing up on the regulator, the next thing to do is to cut this to length, thread a portion and file a portion flat for the little handle. And so to decide how long to make that, I put the bottom of the water sight gauge in place. I also got the blower handle out here. This is a small blower valve that we made, and the hole isn't drilled and tapped yet, but I put it in place. You can see how far it sticks out. It's about the same as the back of the water sight gauge. So if I set the regulator in place with the flange lined up with the bushing right here, you can see the steam inlet is basically centered. So I want the handle to clear the water sight gauge as much as possible. So what I thought is I'll cut it off about here, and then I'll have this portion here I can file to a square, and then have this portion here be threaded. So, and also marked in blue on the top with the throttle closed, so that when I have the regulator, it can be cocked over to the right here, just so it just clears the blower. But when I open it, it'll be probably vertical, and then wide open will be over to the left. Here's the back end of the throttle rod. I squared it off. Should be 133 thou, which is the biggest square you can get inside a 3/16 inch piece of rod. So obviously I used the 5C collet block and that little extra piece of 3/8 inch material. I put some slices in it to give it some compressibility. We've got the throttle end in the lathe. As you can see, I've got the last little, it's a little bit more than 1/8 of an inch, turned down to an 1/8 inch diameter, so I can thread it number 5 by 40 threads. And I've got the little flat part. I milled it to 133 thou, and then I filed it a little bit, so it's going to be a little bit more than an 1/8 inch square, which will be just fine for the regulator handle, but pretty pleased with how it came out. Alright, now that the pin has the threads on it and the filed square portion, the only thing left to do is to make a little handle, and then we'll be done with this regulator project. So I've got a blank of steel prepared here. I'm using a piece of 3/16 inch cold rolled. I'll just drill and tap. I think I'll use a 440 for the handle part, and then the number 33 drill here. Mill this down to 3/32, and then shape it, and we'll be done. So I'll bring you back as we make some progress on that. Made the little handle out of a piece of 3/16 inch brass. It's threaded 440 here, and I did a little straight stem about an 1/8 inch thick, and then did a little tapered handle. I'm getting ready to cut it off. You're doing well. This will be the last segment for this week's episode, and I've blued the handle here, shaped it on the belt sander, blued it, made the little brass handle, and I made a little brass hex nut, 1/4 inch brass, tapped at 540, and I did leak test it, and the mechanism works fine for cutting off. So I'm very excited about this. Very much appreciate John Baguley for posting this on the internet and giving me the idea to make this. And as I said, as I pointed out in this video, the dimensions and so forth are basically patterned after the Rob Roy, all except for the distance, which is smaller because the boiler's a little smaller. So if you would, please give me a thumbs up if you're interested in this, and ask any questions that you might have. I'll do my best to answer them, but the thumbs up do motivate me, and it's just nice to know that people are watching out there. I do appreciate it. Appreciate the growth in the channel. I appreciate everybody who's been along on the journey. So thank you so much, and I'll keep you posted. The next thing I think I'm going to do, or the next chore, of course, is to start to drill and tap the various, there's a few bushings on the boiler that need to get drilled out, and that'll be an interesting process in and of itself. So thanks again, everybody. We'll see you soon. Bye-bye.